All right, I got 3 distinctly different tapers there, and we're going to see what each one does. I'm going to gap them the same, make sure they got the same arc gap, same travel speed. I'm going to cool it off completely in between each bead. Even with that blunt tip, I got a pretty nice crisp start because it's a really good finish from the diamond wheel. Show you the wrong way. Coarse scratches running sideways with a blunt tip can really be a problem on arc starts. You know, that arc could wander over to some little thin cooling fin or something next to where you're welding and melt it off. Could be a big problem. Here's in slow motion just because I thought it looked cool. All right, back on track here. That's a nice stable arc with a fairly narrow arc cone, and that's the result there. All right, now I'm going to let it cool off, and I'm going to make sure it's cooled off with my little IR gun there. Trying to get it to right at 75 degrees every time, close enough. And we'll come next to it, maybe an inch or so away, try to do everything the same arc gap. Don't wait around when we start the arc, get things going. And I'm going to cut all these the same distance from the start point, just try to keep everything the same and not have the results skewed from a level of preheat or something. Now that's also a nice stable arc, and the arc cone's a little wider. A nice bead. A little bit better looking bead overall as far as the ripples, the appearance of the ripples and everything, but you know, it is what it is. Lastly, the needle sharp electrode. This is actually a very useful type taper here if you need to weld something thin and you don't have the right size electrode. You get a really crisp start and a really stable arc at low amperages, even if you're using one size too big electrode, or even 2 sizes too big sometimes. I've seen box cutter blades even welded with a 1/8 electrode with a tip tapered way back like this and even polished to get a good start. All right, so the first bead is the narrowest bead. That's just like the books tell you. Second one's a good bit wider, but the third one is not quite as wide as the second one. Have no idea why. But I'm going to cut them. I'm going to cut a little section out right here. I'm going to use the Metabo Slicer Plus cutting wheel with a 6-inch Metabo, and it's going to make short work of this. A little polish on the cross section. The better you polish something, the easier it etches. I didn't have really good polishing equipment at my shop on this particular day, so I just used Scotch-Brite. And the acid etch is a sort of a passivation solution normally for stainless steels to remove the heat tint. Now that's the result that this electrode prep gave. I'll help you out a little bit by drawing a line to define the weld nugget. The big area is the heat affected zone. The smaller area that looks kind of grainy is the actual weld nugget. All right, that's the second more tapered electrode, and here is the last one, the needle sharp electrode, and everything is shallower here, the heat affected zone and the weld nugget, just like the books tell you, but I wanted to see so for myself. Let's get another quick look at these arc starts, and I'll just puddle here momentarily, just kind of remind you what things looked like. The arc cone here was pretty narrow, and that was the result. On the second electrode, a little bit more taper, a little bit more wider arc cone, but a really nice crisp start, and that yielded this weld nugget right here. And then the last one again, which is really weird, that little weird halo that's coming out midway. I think that's to do with the temperature of the electrode. It's getting really hot in that area, and something's happening different than on the other electrodes. And the result was this. I wanted to do one real weld here using filler metal with that most blunt taper just to kind of see if it still flowed good, still got a good arc start and all that, and it is doing a pretty good job. And I had the camera kind of in the way here, so I couldn't really optimize this, but I can see the benefits of using a little bit more blunter electrodes than what I've been accustomed to, especially when I want to keep the bead a little narrower and punch it in there real good.